Hi y'all, welcome back. So in the next part of the video, we'll go over part D. Part D. Okay, so what does part D ask? Part D, they ask you to perform the momentum balance for the streamwise direction, the last one. But before that, they ask you something about pressure, okay? So they actually ask you what is the pressure is a function of. So pressure is a function of what? Of what? Okay. Okay. So previously we know what? Previously we know, okay, let me write from part C. We know that. We know what? We know that pressure is not a function of x and pressure is not a function of z, right? So from here we can imply that pressure must be a function of y. Now, you have to notice something very interesting. So you have to notice that at x equal to h, any I, any y, pressure equal to atmospheric pressure P infinity. Okay? So, or you can say this is at this free surface. Okay, so what does it say? So it means that pressure at x equal h, any y equal to P infinity. P infinity. Alright, what does it mean? Since we already say that pressure doesn't depend on x, so this similarly, so it means that pressure as a function of y equal to P infinity. Okay, y from that previous line, we imply this line because we have shown that pressure is not a function of x. Okay, so if py equal P infinity, it means that no matter what time in space, no matter what happened, pressure is equal to pressure infinity. So pressure is a constant. So what does it mean? It means that at first you see this logical reasoning. At first we say, oh, pressure is a function of y. And then later we arrive at, okay, that function of y it turns out to be a constant, P infinity. So our pressure is equal to a constant, which is P infinity. Okay, with that chain of logical reasoning, you conclude that two things. Pressure is not a function of x, y, or z. And what that being said, since pressure is not a function of y, the partial pressure with respect to y equal to 0. This will be very, very important analysis later. Now we're ready. After the seatbelt is being on, we can perform the momentum balance in the streamwise direction x, right, or y, or streamwise. This is actually y direction. Y direction momentum balance. Okay, what does it say? So it's rho times partial v over partial t plus u times partial v over partial x plus v times partial v over partial y plus times partial v over partial z equal negative pressure over partial pressure over y plus viscosity mu times partial squares of v with respect to x plus partial square v with respect to y plus partial square v with respect to z plus rho times g times y. Okay. So it's not g times y, I'm sorry. Ty. Alright. So can we simplify this equation? Yes, we can. This term vanished because, again, this is steady state. Okay, this term vanished because u equals 0. This term vanished because of the continuity equation. So partial v equal partial y is 0 from continuity equation. Okay. This term vanish because w equals 0. This term vanish because we have proven above. Let's see other terms. This term cancel out because, again, because of the fact that the first derivative equals 0, so the second derivative also equal to 0. And this last term cancel out because we have reason above, so v is not a function of z. So partial v over partial z equals 0. And if the first derivative equals 0, the second derivative equals 0 as well. Now, what about gy? Okay, so what term is left? You have this term left. This term left. So what you get? You get mu times partial square v over partial x plus rho times gy equals 0. Okay, now what is gy? First of all, is gy 0? The answer to you is no. If you look at the picture again, they give you something like this. So if you look at the picture, they say chi is going down, something like this, right? So that's gravity component, and you know it's a y component, right? So what's gy in terms of chi? So if you draw the coordinate, okay, and if you assemble it, if you move it into the y coordinate, so this is the chi component. Let me do it in red. So this is the chi components for y. So in this case, gy is equal to negative chi. Okay, because chi is a positive number, but when you put it in the y coordinate, is negative. So your gy have to have the minus sign from chi. Okay, so now we have that. We can substitute it in gy, and we can say mu times partial square v over partial x minus rho chi equal 0. Okay, now let's make sure the second derivative term appear on one side, and then we can start doing some solving. Okay, so let me rearrange a bit. So mu times partial v squared over partial x squared equal rho chi. Okay, so you can say partial v squared over partial x squared equal rho chi over mu. Okay, so in the next video, I will show you how to obtain a velocity profile, and I'll thank you for your attention.